Hello, science fans! Welcome back to another deep dive into the fascinating world of technology and information. Today, we're diving into the world of data, something that powers almost everything we do, even if we don't always see it. Think about all the information around us, your favorite songs on your phone, the endless items in online stores, or even your school grades on a computer screen. But have you ever wondered how computers keep all that information organized, accessible, and up to date? The answer is data models. A data model is like a blueprint for information. Just as architects use blueprints to design buildings, software engineers use data models to design how information is stored and managed. It shows what data we need, how it all connects, and the rules for how it should be used. Without a plan, things get messy fast, like trying to build a house with no blueprint or instructions. You'd end up with chaos instead of a sturdy home. Imagine a library where books are just piled everywhere with no shelves or system. Finding anything would be nearly impossible, and you'd waste hours searching. But with organization, like labeled shelves and a catalog, you can find exactly what you need in seconds. That's what a data model does for computers and apps. It keeps data accurate, consistent, and easy to use, so systems can work smoothly and reliably. Data models help apps show you relevant products, suggest new music, or display posts from your friends, making your digital experience personal and efficient. They're the foundation for any system that uses information, from small apps to massive global networks. Data models are also a powerful communication tool between system designers, developers, and business users. They help everyone agree on what's important, how information should be handled, and what the system needs to achieve. A good data model turns business ideas and requirements into a clear, logical plan that a computer can follow step by step. It ensures systems do what we need them to do, whether that's tracking sales, managing inventory, or connecting people. That's the power of a solid data model. It brings order, clarity, and reliability to our digital world. So, let's explore the building blocks of data models and see how they shape the technology we use every day. Every data model is built from 4 key parts: entities, attributes, relationships, and constraints. These elements work together to create a structure that helps us organize, understand, and manage information in a logical way. Entities are the main things we track, like student, teacher, or book. In any system, entities represent the core objects or concepts that are important to the business or organization. An entity is a category, not a specific thing. For example, student is an entity, but Alex Johnson is a specific instance of that entity. Attributes are the details about each entity, like first name for student or title for book. Attributes describe the characteristics or properties that make each entity unique. Think of an entity as a folder, and attributes as the info inside. Each folder holds many pieces of information, and those details help us tell one entity apart from another. Relationships connect entities, like a teacher teaches a course, or a student enrolls in a course. These links show how different entities interact and depend on each other. These connections show how data fits together. Without relationships, our data would be isolated and much less useful. Cardinality tells us how many. One teacher can teach many courses. One student can enroll in many courses. Cardinality defines the rules for how entities relate to each other, whether it's one-to-one, one-to-many, or many-to-many. Constraints are the rules, like every student must have a unique ID, or grades must be A to F. Constraints set boundaries and requirements that keep our data meaningful and reliable. Constraints keep data accurate and prevent mistakes. They help enforce business logic and ensure that only valid data is stored in the system. They make sure the system works as intended. By applying constraints, we protect the integrity of our information and avoid costly errors. Entities, attributes, relationships, and constraints are the building blocks of every data model. Together, they form the foundation for organizing and managing data in any organization. Without them, data would be chaos. Imagine trying to find information in a pile of unorganized papers. These concepts bring order and clarity. They help us organize, connect, and protect our information. By using these building blocks, we can create systems that are efficient, reliable, and easy to use. That's how we turn real-world rules into digital order. Data modeling translates the needs of a business into a structure that computers can understand and manage. With these basics, we can model anything. From simple lists to complex systems, these concepts scale to fit any challenge. Next, let's see where these ideas come from. Understanding their origins helps us appreciate why they matter so much today. It all starts with business rules. Let's dive in and explore how business needs shape the way we model data. Where do entities and relationships come from? Business rules. Business rules are the real-world policies that shape how organizations work. For example, a professor can teach up to 4 classes, or a student must declare a major by year 2. We discover these rules by talking to people and reading documents. They're everywhere. By gathering business rules, we build a model that truly fits the organization. Now, let's turn business rules into a data model. This is a crucial step in bridging the gap between what the business wants and how we represent that in a structured, logical way. By translating real-world needs into a model, we create a blueprint for our data systems. Take the rule. A customer can make many orders. Here, we identify 2 key entities: customer and order. These are the main objects our business cares about, and they form the foundation of our model. Draw 2 boxes, one for each entity. This visual step helps clarify what we're working with and sets the stage for defining how these entities interact. The verb make in our rule shows the relationship between customer and order. Relationships are the glue that connects entities and tells us how data points relate in the real world. Many orders means a one-to-many relationship. One customer can place multiple orders, but each order is linked to just one customer. This is a common pattern in business data. We connect them in our diagram, drawing a line to represent this relationship. This step visually reinforces how the data will be structured. Next, we add attributes. These are the details we need to know about each entity, like customer name and shipping address. Attributes help us capture the information that matters most to the business. For order, we might include order date and order total. These fields allow us to track when an order was placed and its value, which are essential for business operations and reporting. To link them, we use a customer ID in the order entity, a foreign key. This ensures every order is connected to the right customer, maintaining data integrity and traceability. Let's look at another rule. Every employee must belong to one department. Here, our entities are employee and department, and the relationship is belongs to. This means one department can have many employees, but each employee is assigned to only one department. This structure is vital for organizing teams and managing resources. This is both a relationship and a constraint. Constraints help enforce business rules, making sure the data stays accurate and consistent. We design the system to enforce these rules automatically, so errors are minimized, and the business logic is always followed. By breaking down each rule, we build a model that matches reality. This process ensures our data structure truly reflects how the business operates. Each piece fits together to reflect the real world, creating a complete and accurate picture of the business in data form. That's how we turn business needs into a working data model, step by step, translating requirements into structure. Next, let's talk about naming, which is key to making our models clear and easy to use. Naming matters a lot. Clear names make your data model easy to understand. Use simple, singular nouns for entities: customer, product, order. For attributes, be descriptive. First name, shipping address. Avoid abbreviations and vague terms. Be consistent. If you use customer ID, stick with that pattern for other entities. Pick a naming style and use it everywhere. Good names turn your model into a clear story anyone can follow. They reduce confusion and speed up development. When new people join, they can understand the model quickly. Clear naming is a small step that pays off big. Don't just name it well. Now let's see how data models have evolved. Data models have changed a lot over time. In the 1960s, we had hierarchical models, like family trees, but very rigid. Then came network models, allowing more flexible connections, but they were hard to manage. In 1970, Edgar F. Codd introduced the relational model, data in simple tables, linked by common values. This made databases much easier to use and design. The entity relationship, ER model, gave us the visual language of boxes and lines. With object-oriented programming, new models stored data as objects. Today, NoSQL models handle huge unstructured data, like social media posts or sensor data. Each step solved new problems as data grew more complex. The evolution of data models is about making data easier to organize and use. From rigid trees to flexible graphs, models adapt to our needs. Understanding this history helps us choose the right model for any job. Now let's look at how we view data at different levels. That's data abstraction. Data abstraction lets us manage complexity by looking at data from different viewpoints. There are 4 main levels. The external level is what users see, customized views for different roles. The conceptual level is the big picture blueprint of all data and rules. It's independent of any specific technology. The internal level shows how the conceptual model is implemented in a database: tables, indexes, data types. The physical level is the deepest, how data is stored on hardware. Most people never see the physical level, thanks to abstraction. Each level hides unnecessary details, letting us focus on what matters for our job. Abstraction makes data systems powerful and manageable. It lets users, designers, and engineers all work at the right level. That's how we keep complex systems under control. With abstraction, we can build, use, and maintain data systems efficiently. It's the secret to handling big, complicated data. Now let's wrap up our data adventure. Here's what we've learned. Ready for a recap? Let's go. We've covered a lot. Data models are blueprints that organize and protect information. Entities, attributes, relationships, and constraints are the building blocks. Business rules shape the model, turning real-world needs into digital structure. We explored the evolution of data models and the power of abstraction. Each concept helps us build systems that are reliable and easy to use. Understanding data models is key to making sense of the digital world. Let's see why this matters. Data is everywhere, and a good data model is essential. It's not just for computer scientists, it's digital literacy for everyone. Knowing data modeling helps you ask better questions and make smarter decisions. For businesses, it bridges the gap between needs and technology. For programmers and analysts, it's the foundation of everything. A good model leads to efficient, reliable systems. A bad one causes endless problems. In science, it ensures data is organized for real insights. Learning data modeling is learning to think clearly about information. It's a superpower for building, understanding, and improving the digital world. Keep exploring.